This is 2.1 function notes. Okay, we're going to start off with function notation. So I want you to let f of x equal 3x squared plus x minus 5. And remember, function notation is just f of x. And I want f of negative 2. So remember, you're going to plug in negative 2 for every x value. So you're going to have 3 times, parenthesis, negative 2 squared. Let's plug in your negative 2 for this x value and minus 5. You should be able to do this without a calculator. 2 of 5. For your next problem, I want you to do f of a. So plug in a for every x value. That's going to give you 3a squared plus a minus 5. For c, I want you to plug in f of a plus 2. So 3 parenthesis a plus 2, that quantity is going to be squared, plus a plus 2, and then subtract 5. Right here, you're going to have to double distribute. I would probably do this first. So that means this is going to be a squared plus 4a plus 4, 2, and subtract 5. If you'd like to go ahead and combine those, you can. Now distribute your 3 in. Then go ahead and combine your last terms. For D, how about 2 times your quantity f of x? So that should just be 2 parenthesis 3x squared plus your x minus 5. That will give you 6x squared plus 2x and minus 10. Okay, for E, let's try f parenthesis a plus h. Okay, we've done this, we did this on C. I want to subtract f of a, which we did on B, and I want to divide this by h. Okay, I'm going to do this. I'm going to try to break this up as easy as possible. Remember, a plus h goes in for x. Then we're going to subtract when you plug in an a value. Okay, I'm going to use brackets to help you out here. So this is going to be a 3 parenthesis, plug in an a plus h into your x value, square it, plug this should be a plus, an a plus h minus 5. So I'm plugging in an a plus h into that first function equation. Now I'm going to subtract plugging in an a. Okay, I'm going to divide all of that by the letter h. Okay, I'm going to do like I did on C, and I'm going to double distribute this first. I am going to go ahead and distribute this negative here, so this is minus still over h. Please keep writing that. Okay, now I'm going to distribute my 3. Okay, now I want you to look. I will tell you that almost always this last parentheses will be able to cancel out. So my 3a squares are gone. My 5 is gone, and hopefully my a is gone as well. Bring down everything else. I'm over h. You notice on the top everything has an h. That means you can factor it out. You can't just cross them out. You need to factor. If you take out an h on the top, that gives you a 6a plus 3h plus 1 over h. Now that you have factored out the h, you can cancel it, so that your final answer is 6a plus 3h plus 1. So if you have a problem like y equals the square root of x, anytime you have a square root problem, what I always do is take what's underneath the square root and set it greater than or equal to 0. So if you need to solve anything, this one's already solved. So if you have to solve anything, this helps you, and then this gives you the answer. So in this case, putting it in interval notation, you get you get 0 to infinity. And remember, infinity is always parentheses, and this one's going to be bracket because it's equal to. If I give you the problem, if you have a fraction, anytime you have a fraction, remember fractions, you can't have a 0 on the bottom. So what I do is I set them equal to 0. Remember, these are asymptotes, so they cannot equal 0. These are vertical asymptotes. So if you just set them and say they're not equal to 0, then your answer is going to be everything else, or you can do your number line, which will also be helpful. In this case, I know it can't be anything else. It can be everything but 0 because 1 is on top. So I'm going to say negative infinity to 0, union 0 to infinity. If I give you the function of 1 over x squared minus x, the first thing that I would do is factor out the x on bottom. Okay, remember the bottom is your vertical asymptotes. So I set those just like up here with a fraction, you set them equal to 0. We know that we can't equal 0. So that means if I set that to 0 and I set minus 1 to 0 and solve, that means that we can equal 1 and we can equal 0. These right here are vertical asymptotes. Okay? Since there's a 1 on top, there's really nothing to solve. You could do your number line to help out and to double check to make sure that nothing else is going to be in your domain. But since the 1 is up there, it's not really going to help you. So in this case, my domain is everything but these two numbers. So I'm going to say it's negative infinity to 0, union 0 to 1, union 1 to infinity. So everything but those two. Remember, those are your asymptotes. A square root like we did up here in the example, or I showed you. So the function of the square root of 2x minus 3. Like I did up here, I'm going to take 2x minus 3, ignoring my square root, set it greater than or equal to 0. Remember, under a square root, you can take the square root of 0, but you cannot take the square root of negatives. That's why I say greater than. When you solve this, you get x is greater than or equal to 3/2. This just gave me the answer right here. So my domain, I should have said domain over here, sorry. So my domain is 3/2 to infinity. Infinity has a parentheses. Because this is equal to, I can take the 3/2, I can take the square root of 3/2 because this would give me 0. I'm going to say the function with x over the square root of 1 minus x. Let's really change this up some. Okay, so I'm going to set this, because it's on the bottom, I'm going to do this first and say that because it's on the bottom, that it can't be 0 because that's like your vertical asymptote. So 1 can, I guess I should say it the other way. 1 cannot be x, or x cannot be 1. I also need to worry about the square root. Let's do this. Because it's in the square root, I'm going to say 1 minus x has to also be greater than or equal to 0. So negative x has to be greater than 1, or x has to be less than or equal to 1. Sorry, this was negative 1 and this is 1. Remember, you flip your sign when you divide by a negative. It can't be 1, but it has to be less than or equal to 1. I'm thinking that if we go to negative infinity to 1 and not include it, then that's going to take care of this one and this one at once. And there's my domain. How about the function? Let's do the square root of x squared minus 2x. Okay, with your square root, again, I just take it out, set it greater than or equal to 0. So x squared minus 2x is greater than or equal to 0. This is factorable. So this gives me x minus 2. It's greater than 0. You can now set those basically equal to 0. So x equals 0 and x minus 2 equals 0. So x is 2. This right here is a quadratic. I'm going to go back to our last chapter and I'm going to graph these. If this is 0 and this is 2, and this is a quadratic, it's positive, so it's going to graph up like this. At 0 and at 2, since this is equal to, I know this is closed. And because it needs to be greater than on this quadratic is going to be shaded up. Looks like my answer will be negative infinity to 0. This is going to be included. And let's go to 2, include it to infinity. Number 1 says let f of x equal 1 over x minus 2 and g of x equal the square root of x. So we have a rational function and we have the square root of x, and we are going to combine these to find the domain. And some of these might be an intersection. All right, so let's look at this. This means exactly what you think it is. We're going to add the two functions together. And if we add the two functions, we've got 1 over x minus 2. And if we add the square root of x, there's nothing that we can do with these. This is actually the answer. And if we want to find the domain, on this first one, if you want to find the domain, then basically x cannot equal 2. And on this one, x has to be greater than or equal to 0. Whoops, 2. Sorry about that. And x has to be greater than or equal to 0. So we write the domain for this. Then I would say that, that 0 is included, and we're going to go to 2. Then we would union 2, and we would go to infinity. Okay, for this one, when we want to subtract the 2, then I would say that 1 over x minus 2, and we're going to subtract the square root of x. And again, I cannot combine these, so this would be my answer. So again, x cannot equal 2, and x has to be greater than or equal to 0. So it looks like my domain is going to be the same. Right here, this means I'm going to multiply the 2. So if I multiply the 2, then get the square root of x over x minus 2. Okay, because this is on the bottom, x still cannot equal 2. I still need to worry about this function right here because I've got a square root, so x still cannot equal 0. It looks like my domain is still staying the same. All right, when I divide f by g, so my function f by g, it looks like I need to leave, change flip. So I can just multiply by the reciprocal, and I'm going to have 1 over root x times x minus 2. Now because this is on the bottom, I no longer can be equal to 0, so x has to be greater than 0, and x still cannot be 2. So the only thing that's going to change with my domain now is that I can't have a bracket, so it's going to be all parentheses, and that's the only thing that changes with my domain. The most common mistake here is that everybody distributes a 4. When you have a 4 outside, this means that you're going to substitute the 4 in for x. So take your f function. Your f function is x minus 2. Replace the 4 in for that. I'm going to add my g function, which is the square root of x, and I'm going to replace the 4 in for my x. So I'm going to simplify this. I'm going to add that together and get 2.5, or that is 5/2. And that's your final answer.